Lesson 3.4 deals with factoring again, except we're factoring now perfect cubes. So if we recall how to factor a difference of squares, we remember that if we have a problem that says x squared minus 25, we remember that that gets split into two binomials, an x and an x, because the square root of x squared is x and x. The square root of 25 is 5 and 5. Remember, one is plus, one is minus. So we're going to kind of think about that a little bit today as we move into perfect cubes. So one of the ways that we could have written this general equation is to say a squared minus b squared. This is the general form of difference of squares. Well, the square root of a squared is a. The square root of b squared is b. One's plus, one's minus. So we're going to think about that as we move into today's lesson. So sometimes there are special polynomials in which we don't need to split the middle or use the quadratic formula. We have special formulas for perfect cubes. So perfect cubes. We are going to make a list over here of perfect cubes. X cubed. This side with the x cubed is called the perfect cube. And this side with just the x is called the cube root. So if you don't know your perfect cubes, that's fine. I'll show you on your calculator how to find that and use that. So if I say, what is 1 cubed? You'd say, well, 1 times 1 times 1 is 1. 2 cubed, 2 times 2 times 2 is 8. 3 cubed, 3 times 3 times 3 is 27. Now in your calculator, you're probably doing 3 times 3 times 3 and 2 times 2 times 2. Well, on your calculator, let me bring it up and show you how you can easily do this. Okay, so when I pull the calculator up, the writing is going to go away, so make sure you have this down. So on the calculator, we have this button here, so let's do 4 cubed. You're going to type 4, and then do you guys see this caret button? It's above the division sign. Okay, 4 raised to the 3rd power. So that's going to give you the exponent. Now some of you, it actually switched into exponent mode when you did that. Switched to a small little number, and that's fine too. And then we'll push enter. 4 cubed is 64. So when we go back, we would say 4 cubed is 64. So then we could say 5 cubed, 125. Again, we're going back to our calculator. And we can do 6 raised to the 3rd power. It's 216. Go ahead and try 7. $343, and then that's really as far as we will go. We won't really use, we might use 10. 10 cubed is 1,000. We won't really go farther than 7. Okay, so this is a quick glance for us. Now the question is, how do you go the opposite direction? What if you were trying to figure out, I don't know, is 496 a perfect cube or something like that? So if we wanted to check to see if 496 was a perfect cube, let's pull up our calculator. Now, watch carefully where my mouse is going. I want to get the cube root, and if we look on our calculator, there is nowhere that's the cube root. So instead, I'm going to push math. Math is right below the green button. And you can see option number 4 is the cube root. So you can hit 4, and it brings up the cube root on your calculator. And what did I say? 496. Is that a perfect cube? No, it's not. So let's try that again with one that we know for sure. Let's try the cube root of 125. So again, I'm going to go to Math, option 4. I'm going to type in 125. So is the cube root of 125 a perfect cube? It is. And we knew this already because we already found that it was 5. So that's how you can go between cubing and cube rooting. Okay? So let's look at these formulas that they gave me. I have the sum of cubes and I have the difference of cubes. Remember, sum means addition. So sum means addition. Difference means subtraction. You're going to know which formula to use based on the sign of the problem. So if you look at number 1, there's a subtraction sign, so that means we're going to use the difference formula. Now let's look at the difference between the two formulas. So I have an a plus b, and then I had an a minus b. So right now, the only difference between these two are the signs. Then I have an a squared plus or minus an ab plus b squared. So then the second difference is these signs. So everything else is the same in the problem as far as what variables go in which position. Okay? So the thing that you're going to have to remember and sort through is the signs. So if we look at example number 1, it says x cubed minus 125. So the first thing that I like to do is to set up my formula. I know that this is subtraction, so I'm going to set up my subtraction formula that says a minus b, a squared plus ab plus b squared. So all I did was set up my formula from over here. Now to find the a value, we're going to ask ourselves, what is the cube root of x cubed? Well, the cube root of x cubed is x. And then I would ask myself the same question, what is the cube root of 125? And if you look over here at our chart that we made, the cube root of 125 is 5. So that becomes my b value. I'm going to just put the sign down because I always have to follow the sign of the formula, not the sign of what I think it should be. So that's how we get a and b, is by taking the cube root of the first terms that they gave me. Now the formula says to take your a squared, or take your a and square it. So remember, our a value is this x over here. So if I take that a value and square it, that gives me x squared. Now it says to take the a value times the b value. So my a value times my b value is going to be x times negative 5. But for the sake of the formulas, we're not going to think about the sign. We're just going to do x times 5, and x times 5 is 5x. And even though we think it should be a negative 5x, the formula says that it needs to be positive. So we're going to put a plus sign there. Then it says take your b value and square it. So my b value was 5, and if I square 5, 5 squared is 25. And I can put a plus sign because that's what my formula says. So I have x minus 5 times x squared plus 5x plus 25. That would be fully factored difference of cubes. If you wanted to, you could set up a box and multiply it back through, or set up distributive property and multiply this back through, and you would get x cubed minus 125. So let's try example 2. The first thing I notice on example 2 is that there is a common factor. You guys see on example 2 I can pull out an 8 first. So if I divide everything by 8, remember the 8 comes on the outside and I have y cubed minus 8. Now that is not my a and b. This is where students get confused. Students think, okay, now I divided something out, so now I have a and b values. You don't have a and b values because you didn't find the cube root of anything yet. So now that I've pulled out the common factor, now I can factor this y cubed minus 8. It is a subtraction problem. It's a difference of cubes. So again, the first thing I'm going to do is write my formula down, and I would strongly encourage you to do this until you get the hang of it. So for these examples, we're going to go ahead and write this down. A minus b times a squared plus ab plus b squared. So remember, in order to get the a value, we're going to ask ourselves, what is the cube root of y cubed? The cube root of y cubed is just y. What is the cube root of 8? Well, it's 2. Formula says minus. This other 8 that is sticking out here, the other 8 that's sticking out, we're going to kind of forget about it until the end. Okay, so we're going to set it off to the side and we'll bring it down at the very end. So now it says take your a value and square it. My a value is y, so this is going to be y squared. Take your a value times your b value, so remember my a value and my b value are y and 2. So y times 2 is 2y. Remember, we're going to use the sign that the formula says, so we're going to put a plus sign. And then b squared, so b squared was 2, and 2 squared is 4. We're going to use a plus sign. Now we can bring down our 8. So now I'll bring down an 8 and stick it out front. This is my final answer. Never should you get over 100 in your formula when you factor it all the way out. Sometimes I'll look at students' papers and they'll have like 172,532. That is incorrect. You should not have over 100, a number that's over 100 in your factors. That means you have done something incorrect. Okay, let's go on to example 3. Like I say, example 3 says 192u cubed plus 375. Now if you look back at your chart up there, 192 and 375, neither one of them are on our chart. So let's just double check with our calculator. Is 192 a perfect cube? Okay, so remember we go to math, option 4, 192. We get 5.76. Okay, so that's not a perfect cube, which means we're going to have to pull out a common factor first before I can do anything on this problem. So if I look at 192 and 375, I can't divide out by 2 because 375 is not an even number. So let's see if we can divide each of those by 3. And we want to get a perfect cube when we divide. So 192, if I divide it out of 3, that goes evenly and it's 64. Look at your list up there. Is 64 a perfect cube? Yes. Okay, so now let's check 375. Can we divide that by 3? We get 125. Is 125 on our list? Indeed it is. So if we divide this problem by a 3, we are going to get perfect cubes that we can then apply our formula to. So I'm going to divide by 3 first. So all I'm doing is pulling out the GCF. I'm not factoring, I'm not using my formula. plus 125. So 64u cubed plus 125. I'm going to hold off that 3 till the end, and then this is what I'm going to use for my cube formula. This is an addition problem, so I'm going to use my addition formula, or my sum of cubes formula. So my sum of cubes formula says a plus b times a squared minus ab plus b squared. So I just wrote the formula down from up above. Again, I knew I needed the addition problem, the addition formula, because this is an addition problem. So now remember, in order to get the a value, you ask yourself, what is the cube root of 64u cubed? Okay, well, what's the cube root of 64? We have 4, and the cube root of u cubed is u. Now these two need to go together. The 4 and the u go together because the 64 and the u cubed are together as one term. That's why the 4u also needs to be together as one term. Okay, then I have my plus sign. And then I'm going to ask myself, what is the cube root of 125? And the cube root of 125, we know, is 5. All right, now this is saying take your a value and square it. If I take 4u and square it, 4u times 4u is not 4u squared, it is 16u squared. Right? We have to square the 4 and the u, so be really careful about that. 16u squared. Now it says take the a times b, so 4u times 5 is 20u. We need to subtract it. Take the b value now and square it, so 5 squared, 25. The only thing we are missing now is that 3 from up above, so I'll bring my 3 down out front. This is going to be my answer. 3 times 4u plus 5 times 16u squared minus 20u plus 25. All right, let's look at example 4. It says 8 plus 27x cubed. Now, 8 is a perfect cube, and so is 27. Does it matter that they are out of order? You'll have to forgive me, I just paused it, and I don't remember my train of thought. So, let's get back to this. Sorry about that. One of the first things that we can do is not switch the order. I'm pretty sure that's what I was talking about. We don't want to switch the order. Just because the variable comes second doesn't mean that it's actually the a term. My a term is going to come from whatever has been written first. So my a term is going to come from the 8 because that's first. So let's go ahead and write our formula down. A plus b, a squared minus ab plus b squared. So we're going to take the cube root of 8, and the cube root of 8 is 2. Then we'll take the cube root of 27x cubed. Well, the cube root of 27 is 3. The cube root of x cubed is x. Make it plus. Then it says take your a value and square it. A squared, that's 2 squared is 4. A times b, 2 times 3x is 6x. We'll put the subtraction sign. And then plus b squared, so plus 9x squared. Be really careful with that. 3x times 3x is 9x squared. Now, the question is, does the order matter? I don't need you to change the order around in this second group. You can leave it just as is, 4 minus 6x plus 9x squared. All right, let's go ahead and look at example 5, or the next page. So we're going to review a little bit of factoring difference of squares. And we've dealt with this a little bit. But we're going to get deeper into it. Factoring difference of squares. So if I'm factoring a difference of squares here, 4x squared minus 1, so remember we're going back to perfect squares, so we're going back to the a plus b, a minus b formula for factoring, because these are perfect squares, not cubes. So 4x squared minus 1, remember you can ask yourself what's the square root of 4x squared? That's going to give you 2x and 2x. And then the square root of 1, 1 and 1. 1's plus, 1's minus. So this would be finished. Now on number 6, if we look and we say, okay, 100 is a perfect square and so is 64. So again, we're not going to change the order around, because if you change the order around, you're going to get an incorrect answer. So we know that the square root of 100 is 10. The square root of 64x squared is 8x and 8x. One's plus, one's minus. Does anyone see anything wrong with this or unfinished? Remember, factoring means to break it down to lowest terms. And if you look in this first group, I can pull out a 2 from here. And if I look in this group, I can also pull out a 2. So if I can pull out two 2's, that means I'm pulling out a 4. 2 times 2 is 4, which leaves me with 5 minus 4x and 5 plus 4x. This would be the answer you would get full credit for. But what if from the beginning, I have 100 minus 64x squared, what if from the beginning I had pulled out a 4? That would leave me with 25 minus 16x squared. The square root of 25 is 5. The square root of 16x squared would be 4x. And then I would bring down the 4, and I'm getting the same answer. It's best at the beginning to look for the greatest common factor, but if you don't want to do it or you forget to do it, then when you get to this step here, you need to make sure that there's nothing you can do to factor it even more. Always remember to factor to lowest terms. So when you think that you're finished, look again to make sure you can't factor anymore. So let's look at example 7 here. Example 7 says x to the 4th minus 16. So we haven't seen x to the 4th yet, but x to the 4th is a perfect square, right? X squared times x squared makes x to the 4th. And we know that 16 is a perfect square, 4 and 4. So this is still a difference of squares. So we can say x squared. The square root of 16 is 4. One's plus, one's minus. And maybe this would be finished except for the fact that we see here is another difference of squares, right? X squared factors to x and x, and 4 factors to 2 and 2. So we have to go one more level. X plus 2, x minus 2. So I have x plus 2, x minus 2, and I can't do anything with this x squared plus 4 because it's a sum of squares, and the sum of squares doesn't factor evenly and nicely like this. This is going to have imaginary roots, which we've talked about before. So we're just going to leave this one as x squared plus 4. This would be our finished and final answer. So always be on the lookout for hidden factors that have to go another level and be factored again. All right, let's look at example 8. It says factoring polynomials with 4 terms. You actually have already done this. We can factor this by grouping. Right, when we have 4 terms, we're going to always use grouping. So if I group the first 2 together and the second 2 together, now I have to figure out what can come out of each of them. Well, out of 280 and 224, let's use our calculator. I'll use my calculator. Let's see what we can factor out. Okay, let's see if we can divide 280 and 224 by 28. Okay, we can. So we're going to go 224 divided by 56. So let's divide them both by 56. I know that you wouldn't have thought about that on your own. You won't be faced with such huge numbers in your homework today. Okay, so just follow me with this. We can divide both of these by a 56r squared. 56r squared. Because if I divide by anything less than that, then I'm not going to get the same thing in the parentheses, and I'm going to have to continue to keep dividing. So 56r squared. So 280 divided by 56 is 5. 224 divided by 56 is 4. Now, the trick is, what do we need to divide the 245r and 196 by? Well, we want to get this number to be a 5, right? So we want, actually, let me put it down like this. We want this to become a 5r so that it matches. So in order for us to figure out what we need to pull out to get a 5, we can divide 245 divided by 5. That gives me 49. But it's a negative 245, so I'm going to pull out a negative 49. And then let's just double check, what's 196 divided by 49? It's 4. So now that we have like terms, a common factor, they go in one parenthesis, and then the next parenthesis is 56r squared minus 49. Again, that one was kind of a doozy. You won't have to do that much. You're not going to deal with that many or that big of numbers in your homework, but I wanted to show you that no matter the size of the polynomial, we can still factor it. So let's go down to number 10. Let's hop down to 10. 10 is going to be a little easier for us to manage as far as numbers are concerned. So let's go ahead and group the first 2 and group the second 2. And let's pull out what they have in common. I'll give you a minute. So we can pull out a 5x here. which leaves me with 5y minus 6r. What about in that second group? What goes into 15 and 18? Well, it would be a 3, but remember if the first term is negative, we're going to pull the negative. So because that 15 is negative, we're going to divide out by a negative 3. And they each have an r to give up. So negative 3r comes out. Negative 15 divided by negative 3 is 5. My r's cancel and I'm left with y. 18 divided by negative 3 is negative 6r. Now I do have the 5y minus 6r in common. And then I pulled out a 5x and a negative 3r. Complete. Okay. If there are not any more questions, we're going to pause on doing some more examples. Actually, let's do a number 11. Sorry, let's do number 11 one last time. This will be our last problem before we'll go to our homework. Okay, so we have 4 terms, so we're going to group the first 2, group the second 2. I'm going to let you work it all the way out. I'll give you a few minutes to work it all the way out. Keep going. Actually pull out an 8 from 16 and 40. And there is our answer. 2h plus 5k times 5a minus 8b. Alright, so this is factoring higher order polynomials, whether we have cubed, difference of cubes, sum of cubes, a polynomial with a cube. You know how to factor these now. Make sure that if you're doing a difference of squares, that you make sure that you can't continue to factor another difference of squares like we did in example 7. Okay?